Welcome. My name is Nigel Ellis, and I'm an architect on the SQL Data Services team. And for about the next 60 minutes or so, I'll be running you through an update on what we've been doing with SQL Services since we launched at MIX last year. There's been some very interesting changes, and in particular, we've learned quite a lot by engaging with the community. So a lot of what you see here has been driven by the feedback and engagements that we've had with the community and so on. So as I talk about this work here, and there'll be opportunities for you to engage in the upcoming year and to try out this functionality, I really encourage you to do that because that's very useful for us in shaping the service. There we go. Okay, so we're going to talk basically about what's been happening in the service. So what have we learned from the community? What are the patterns and practices that we've actually seen emerging? And moreover, what specifically are the value propositions that we see with database as a service in the cloud? We'll also cover the architecture and breadth of the technology that we'll be offering here. Now, before I do that, I'd like to essentially talk about how we see the spectrum of services and data and the capabilities over the data. So the diagram you see here has three layers to it. The lower layer are the places where your data lives. The second layer are the types of data that you have. And the third layer are the services that you have over that data. Now, I'm a relational database guy, and I started in this industry about 15 or so years ago. What's been really interesting is when we first started working on databases, primarily a database was something that ran on a server. And back in those days, a server was something like a PC turned on its side, right? And the types of services we had over the data was primarily rectangular services. So you could take a relational table, you could load it into a system, you could get it out, and you could run queries over it. So relatively simple types of data. Now, over the time, what we've actually been seeing are essentially more types of data. So you can see there's in-memory data. So there's actually a talk on right now about velocity and in-memory cache that Microsoft's offering. There's multidimensional data, so you could think about business intelligence and OLAP cubes and multidimensional data warehousing. There's XML data and file data. Now, all of these things are starting to be offered in what you may have originally thought of as just being a simple database service. We've actually broadened the types of data that you can store, and everybody's started to take this for granted. So if you wind back, for example, 10 years ago, there was a large emergence of special purpose XML storage systems. Right? And everybody was saying, oh, to store XML, you need an XML database. Relational databases are no good for that. And what we've been seeing over the past 10 years is that's actually changing. Most relational databases now offer XML data storage capabilities. They offer the ability to store blobs and file data and so on. And as the types of data has actually increased across these services, the level of functionality that you expect over them has increased. So if we wind back to our relational database, we really wanted to store data, get data out, and query it. Now, if you look at all the services that we support now, caching, data protection, data scrubbing, analytics, data integration, building and modeling a data pipeline, and so on, those things are now virtually taken for granted. Now, one of the problems with this picture is the level of complexity of the products have also gone up, right? What was previously get, put, and commit, and restore your data is now a lot more complicated. So what we're starting to see is essentially a move away from a lot of knobs on these products to essentially more of a logical-based management system. So you express the intent of how you want to manage your data without actually having to do it. And that's a very, very powerful concept. So at the same time that the capabilities are growing, essentially the management capabilities are trying to move in lockstep with that. Now, where does SQL Data Services fit into the overall picture of what Microsoft's doing? Well, at the base of this picture, we see SQL Data Services. That's the lower layer. And that's what we call a database as a service. And what we mean by a database as a service, we mean it's available, it's in the cloud. Whenever you want to go provision capacity, so provisioning a server or provisioning a database for storage capabilities, it's always available there for you. Now, this is our initial offering from Microsoft. So this is the first database service that we have up in the cloud. On top of that, we're also going to be offering a bunch of other related services over time. So the first service that we're going to be offering at the same time as this relational service is something that we call data synchronization. And the idea with data synchronization is that no matter where your data lives, whether it be on-premise, on a device, on your laptop, and so on, you can remain connected with your data as it lives up inside the cloud, right? So the idea that you don't have to make an either or choice. You don't have to have your data on-premise or on your laptop or up in the cloud. You can actually have your data spread across multiple locations, and it can actually be connected through synchronization. And that's actually a pretty valuable concept for us. Now, this second part of the picture here is essentially how it ties into Microsoft's existing SQL Server offering. So we're using that same data synchronization capability to essentially tie and integrate well with Microsoft's existing database product. So if you happen to be running SQL Server within your enterprise today, and you happen to find some value in the service that we're offering up inside the cloud with SQL Data Services, you can tie those two things together with synchronization. There's a few other gray boxes that you see on top of the SQL Data Services layer. Those three are reporting, business intelligence, and reference data. And those are three interesting services that we'll be offering over time. They're not actually services that we're significantly investing in yet. They're more in an internal incubation stage. But the idea behind offering these three services is that it's not sufficient to just give you relational storage up in the cloud. It's not sufficient to just give you synchronization in the cloud. What you want is a richer set of services over that data. So if you recall the slide where we were talking about the locations that you have your data in, the types of data that you have, and the services that you offer over that data, we'd like to take many of those services and also move them up to the cloud. Now, that's going to take us a while to get there because there's a lot of moving parts and complexity and so on. But we believe the more services you have up in the cloud and the more types of data we can provide services for, the more business cases we can actually support. And we think that's going to be a value proposition for us. So I basically gave a talk here about a year ago. So this is essentially SDS's, so SQL Data Services' first birthday. And I was on stage here, and I described an open web service protocol, where we essentially delivered a database service with a simple storage model for these things called flexible entities. We used REST and SOAP protocols to access it. And what we described was not compatible in any way with the existing SQL Server offerings we have. And what we heard unanimously over the past year is that people really do want a database in the cloud, right? And they want to go one step further. They'd like that database to be relational, and they'd like it to be largely compatible with the existing database offerings that they have today. So what we're planning on doing is essentially supporting the familiar SQL Server relational model. We'll let you use your existing APIs and tools. It's going to be built for the cloud with availability and scale in mind, right? So this isn't just taking SQL Server, installing it into many hundreds or thousands of boxes in our data center, and then letting you connect to it. There's a lot more to it than that. And we'll get into some of the details. The fourth point is really interesting. So when we look at a cloud platform for both data and applications, I'm sure many of you have heard of Azure, or you've been to Azure Track talks throughout the week. Microsoft's making a very large investment in ensuring that we have a very strong platform offering in the cloud. And as part of that, we want the ability for you to be able to host your application. So that's the Azure Compute capability. And this week, we announced the ability for you to run essentially full trust and native code. So previously, in the CTP that was announced in November at Microsoft's PDC, we only support managed code hosting with partial trust. Okay? Now you'll be able to take any of your native CGI-style applications running in PHP, Ruby, Rails, and so on, and you'll also be able to run those up in the Azure Compute framework. That's very valuable. Now, Azure also provides you with simple storage capabilities, but those storage capabilities aren't a relational database. They're flexible, almost property bag storage model, so entity value attribute type model. And with the work that we're doing with SQL services and the full relational model, you'll now be able to essentially use your ASP.NET patterns or your PHP or Ruby patterns and so on, and also have the power of a relational database up in the cloud. So our focus here is to essentially take the best features that we have with SQL Server today in the shrink wrap product that you can buy, and then run that at scale for you within our data centers, solving many of the availability issues. So if you're running SQL Server yourself today, it's not sufficient to just take the CD out, go install it on a server box in your corporation, right? That'll get your database up and running, but it won't address the availability and reliability concerns. What happens if that machine dies? Your database is no longer available, right? What happens if you lose a hard drive on that machine? Your data's gone, right? So clearly, if you're serious about your data, you need to think about backup and availability and redundancy and so on. And we address all of those issues with SQL Data Services. So what's happened in the last year is we've taken the feedback that we've received and we're making a change. So this slide here demonstrates how we're moving from SDS current. So by SDS current, we mean the current data service that's available in OpenCTP format. So many of you may already be using that. If you go to the Azure portal at Microsoft.com, you can sign up for SQL Data Services and .NET Services, and you could be already consuming this service. Now, there's two patterns that are demonstrated on this slide. The first pattern was a pattern that was enabled when we actually announced our service last year at MIX. And that was a scenario where you have data storage running in the cloud, but your application is running outside of the cloud, right? And by that we mean your application could be running on-premise, it could be on your laptop as you roam around the internet, or it could be running in somebody else's data center or your own data center, right? Now in this scenario here, we're talking about what we call a code far scenario. So by code far, what we mean is that the code that's accessing the data is a long way away. And a long way is defined in terms of network latencies, right? So you may see hundreds of milliseconds to round trip from wherever your code's running to go into the data center. The second pattern here was actually enabled when Azure was announced at PDC. And this essentially opened up the SDS data service to a code near deployment. And by code near, we mean taking your application, whatever it is, hosting it in Azure Compute, uploading it to a Microsoft data center, right? Typically the same data center where the SDS data service is actually hosted, and then running the application. And that then takes you into a sort of a two-hop scenario. Your code or your business logic, your web application, is now running close to the data, so it's code near, low latency. And then the use of that application, typically from a browser or a rich client and so on, which is talking to your website, is a code far, which is actually the typical scenario for web applications. Now, how does this pattern evolve with the relational service that we're building? Well, it changes a little, and it actually opens up a third scenario. So if we walk through the slide from left to right, so the first scenario we have was the HTTP REST. So it was a code far scenario where you had an application using RESTful protocols to interact with data. Well, that pattern's still enabled in this scenario, but it's done in a slightly different way. So rather than our data service supporting REST and SOAP protocols, it evolves. So it now supports the TDS protocol. So TDS is Tabular Data Stream, and that's actually the protocol that's used by all SQL Server client libraries in the world today. So whether you're accessing SQL Server through ODBC or a PHP native driver or an ADO.NET client or OLADB, you're using TDS, okay? And TDS is a protocol that can run over TCP/IP, shared pipe, shared memory, and so on. Now, in this scenario here, the way that you get access to the data service through a REST protocol is that you deploy an Azure Compute service that exposes a RESTful protocol head, right? And that could be done very easily using the Astoria technologies. So Astoria is the ADO.NET Data Services Framework. That's a technology that's been out in the marketplace for about 12 to 18 months now. And briefly, it lets you take a data service or some data source, and that data source could be a SQL or relational data source, or it could be a CLI data source, so anything that supports, say, an IEnumerable interface. And it lets you very easily provide a data model to overlay that and interact with that data model using a RESTful protocol. So that's how you'd achieve REST access. So you deploy Astoria using essentially a REST application. That would then interact with the new SQL data services using a TDS, so using an existing SQL client library and the relational model, and then give you interaction to your relational data. The second pattern really remains unchanged, which was you were taking your web application, you were hosting that up in the Azure Compute Framework, and that web application now, rather than talking to the data service using a REST client library, it now talks using a SQL client library. So you can see the same patterns enabled there. And the third scenario is actually a little bit net new. It's a code for scenario, but in this case, rather than using a RESTful or SOAP protocol in code for, you can actually use a TDS protocol. Now, there's different levels of opinion on this one. So is TDS a good protocol to use over the internet? Is it a latency-tolerant protocol? Well, the answer is yes and no. So there's certain access patterns that you can use through TDS, which means that it will work well over a high latency connection. And there's other access patterns where it won't. So I'll give you an example. So in SQL Server, you can batch statements together. So if there was 10 things that I wanted to do against my data, I have two choices, the broad spectrum. I could send one large batch with all 10 statements in it to the service, or I could do 10 individual round trips. Now imagine those things are like insert row 1, insert row 2, and so on, right? Clearly, if I'm in a high latency situation, it's going to be more efficient for me to batch those requests up, make a single interaction with the service, rather than doing 10 individual round trips. Now, what are some of the choices that you have? So why use SQL data services? What is it good for? What are we targeting? And so on. So we pulled together this slide, and it's really a relatively simple model to look at the choices that you have. And by choices, we mean where do you run your database software? So do you run it on-premise? Do you run it essentially with a SQL hoster, possibly in a VM machine? Or do you choose to run it with SQL data services? And there's two axes to this graph. The lower axis talks a lot about the level of control that you have. So if you have more control, you have more friction. That is to say, with the power to control your configuration, you're also taking on the burden of some additional complexity. So in this example here, we have an on-premise SQL server or some other database software, right? Now, with that control, I also take on the burden and responsibility of addressing backup, of addressing how I keep my service highly available. Now, for many of you, that's okay. That's a good trade-off to make, right? For others, it's actually seen as an impediment or a barrier, right? So if you were to break down how much time you spend in your business and how much money on keeping a highly available database server deployment running either on-premise or within your own data center, how much does that take away from focusing on the core of your business? Do you want to be a database expert, or do you want to be an expert in your application domain or the value that you're building for your customers? Now, for many of you, it's a trade-off that, no, I don't want to be a database expert, but I need this degree of control, right? And we still believe there are going to be some scenarios like that. The second scenario is really about saying, well, rather than me running this on-premise myself, I'm going to go to some form of a hoster, right? And what do I get from a hoster? Well, I'm not managing the machine per se. I don't deal with physical machines. I'm dealing with more of a virtual machine, right? And that could, by virtual machine, we could mean that the database itself is actually running in a VM instance at some hoster, or you could actually own a whole of a machine, right? But you're not dealing with physical hardware failures anymore. You're paying somebody to go service those machines for you, to go buy a machine if you need it, go allocate one, and so on. But you're still largely managing the machine yourself. So you still have to deal with the issues of backup and restore. Now, depending what type of hoster you're with, some hosters may provide those services for you. Other ones may only give you a bare metal machine instance and so on. And at the other end of the scale, we have essentially low control, right? So that's where SDS actually comes in. So with SDS, what we're doing is we're saying, well, you have logically a virtual machine allocated to you. That is, it's a virtual SQL server. But that SQL Server box comes pre-configured with high availability and backup and restore, and a lot of the physical management that you typically had to deal with in those other two ends of the spectrum, right? So as soon as you provision a server with SQL services, all those issues are taken care of for you. But that comes with a cost, right? You'll notice that it's at the left end of the spectrum for a reason. You don't have as much control, right? But it's low friction, so you sort of have to balance those two things. The other side of the equation is how many resources you have. So if I'm running my own SQL server, or I've paid for a VM or a full server with a hoster, I have the whole machine to myself, right? In SQL Data Services, where we start is that we're essentially using multi-tenancy on those machines. So when you provision a database with this service, you're getting a part of a machine, right? Now, over time, we believe that SQL Data Services can actually grow to largely encompass the middle market, the hosting market, right? There'll still be some things that you can get with a hoster that we might not provide and so on, but we'll start to essentially work our way up the control axis and work our way up the resource axis. We don't think we'll ever be able to fully subsume it, but we should be able to make essentially a lot of progress towards that. So I'd like to do a little demo here. And what we're going to show is essentially access to SQL Data Services from a PHP application. And where we're at in our product cycle right now is we don't actually have our data service internet facing yet. So we still have our old, or current, if you will, SDS service. Our TDS data service is not internet exposed. So I'm going to be doing a demonstration using Cluster in a Box on my laptop here. So PHP, for those of you who aren't familiar, is essentially probably the most common blogging application out there. So it's a website hosted application. It's completely written from the ground up in PHP, and it's written to use the MySQL database. And when I was looking for a demo, I said, well, I think the type of community we have here, PHP, is very, very popular. So I'm going to see if I can find an interesting PHP application that works with SQL Server. And there's not that many out there. SQL Server working well with PHP is actually a relatively new thing. And Microsoft's been making inroads in making that integration a lot easier in terms of supporting a native PHP driver. Anyway, I found this application out there, and someone was nice enough to port it to SQL Server. And what I'd like to illustrate here is that this is the typical setup that you have with PHP. So you tell it what your name of your database is, you tell it where your database is hosted, and you tell it your username and password. And literally, that's all I did to get this application running. So this is running on the Azure Dev SDK. So we have essentially a web role here, and if I just open this, we can see that it's set up to have 2 instances of my web application. So Azure lets you scale your web application. So this is good because it's a relatively stateless application. And I also have this new attribute here that says enable native code execution equal true. And this is the secret sauce to get PHP working with fast CGI. And then in my project here, you can see I actually have a PHP directory which contains the PHP CGI executable, right? And that's pretty much it. So if we go run this app, it should take us through building. A little slow on my laptop here. And hopefully we'll see a page that's very familiar to people. Okay, so we'll go provision my blog. my blog. Oops. Install WordPress. And what it's doing now is actually communicating with SQL Data Services. And it's created all the tables and given me some top secret password here. So we can just quickly log in. Great. So it seems like things are working here. I have pretty much a working blog. So let's do one quick test here. Let's change my password to something I actually remember. All right, my password's changed, and let's publish a blog entry. So this is Windows Live Writer. Whoops, I missed something. All right, P8, whoops. Writing. There we go. Go turn this on. Save these changes. And hopefully, our blog post can go through this time. Oh, well, I messed my password up. But essentially, if we go back here, there we go. We've got a blog here, and we've got some comments and so on. So not a super interesting demo, but it actually illustrates the fact that you can actually talk to a SQL Server with PHP, right? And one of the things to point out here that I just missed is that this is the data access layer. How do we actually connect to SQL Server? Well, we use the NodeBC driver here, okay? And all I said is I'd like to use the SQL Server ODBC driver. It's actually built into PHP. I'd like to use my database host. Here's my database name. And I'm going to use encryption. So TDS supports essentially SSL as part of the native TDS protocol. So that's pretty straightforward. So let's move on. And let's talk about the logical model that we expose here. So in SDS, prior, we used to have something called authorities, containers, entities. All that's gone, okay? We're back to regular SQL Server concepts. There's one additional concept we have here. There's the notion of the account, right? So if you sign up for the Azure package of services with Microsoft, this will be offered later this calendar year, you have to establish some form of a billing relationship for us, right? We're going to charge for this service. We think there's value in doing that. So the account is the principal person who actually is responsible for paying the bill. So now, under each account, you have what we call a virtual server. So you can have one or more of these. And this is where regular SQL Server concepts kick in, right? So each server has one or more databases. So in SQL Server today, you have a concept of a master database. And in master, it gives you a list of all the other databases provisioned on that instance, right? So you could think of master as being the API endpoint that you talk to do basic server configuration, right? Existing concept. Now, each of those databases will be limited in size. So I'm not standing here and promising you, you can provision this server and you can have 1 million databases and those databases can be terabytes in size. Not possible. Ain't going to happen, right? So there will be some limits on those individual databases. Now, where do those limits come from? Those limits are really a function of the type of availability we want to offer, right? Because if a server goes down, let's say we lose a server that has a copy of your database, we have to go clone that database to another server, right? Now, if that database is multi-terabytes in size, cloning is going to take a relatively long period of time. And in that period, what happens if we lose yet another server that has your data, right? So this starts to speak about the availability SLA. The smaller the database is, the higher the SLA, right? You probably recognize this from your own, running your own systems today. Those servers that have large amounts of information are very hard to keep highly available because when you have a failure, you have to copy a lot more information around. Now, each server has a set of logins, right? So logins are the mechanism that you authenticate with the server, right? And SQL Server supports two kinds of logins today. It supports integrated logins, so that's using Windows security, so Active Directory, identities, and so on. And it supports what are called SQL logins or standard logins. And those are logins that are identified with a username and a password. And in SDS, we start out solely supporting SQL logins, so simple username and passwords. Now, each server has one or more database. And inside of a database, you have SQL users. And SQL users are essentially the unit of authorization, right? So we authenticate a login. A login gets authorized to access a database as a specific user or role, and then users and roles are granted permissions inside of the database. This is not new. This is exactly the authorization and authentication mechanism that SQL Server supports today. So we have an example on the bottom of the slide here. So my server happens to be server1.data.database.windows.net. So server1 at some domain suffix. The database is testdb. My login is Nigel E at server1 at that specific server. And that would map to some specific user role within that database. So in this example, a test user. So the nice thing about the model we're offering here today is that the security model is 100% compatible with what you have with SQL, right? So that's a really nice thing in terms of a barrier to entry to the system. Now, what about these databases? So what do we mean by a logical database? So this is a basic architecture slide for SDS. So we start out with a set of machines in our data center, right? And that could be a few hundred. Over time, it could be a few thousand. And those machines are grouped together into things that we call clusters. So a typical cluster size would be hundreds of machines, right? And those clusters are essentially a pool of resources. Now, onto that cluster, we install a special version of SQL Server. So we're part of the SQL Server product group. So we've taken the existing SQL Server product code base, and we've made some extensions to it. And what we do is essentially we glue those servers together in that cluster using essentially a fabric. Now, of course, everybody claims they have a fabric now. We claim we had it first because we started our project a little earlier than everybody else. But what the fabric does is it glues those servers together, and it gives you essentially high availability. So it can detect if a server goes down very, very quickly. And if a server goes down, it can actually switch the request from one server to another server. Now, how does it know which server that you should actually connect to? Well, that's a function of where your data lives. So you'll notice in these boxes here, we have different colored boxes. So DB5, DB1, DB3. And you'll see the same colors repeating across some of those machines. And what those small boxes signify are actually replicas of your data. So for every user database or every logical database that you have, we keep a certain number of copies, right? 3 would be a typical number, right? So those are what we term replicas. Now, each of those replicas are guaranteed to be in synchronized state, right? So whenever you log into a server and you make an update, what we do is we send those changes to the other replicas. And then we wait for essentially what we call a quorum. So if we have 3 replicas, we wait for 2 copies to actually say, yes, we can commit this change. Okay? The third copy can lag a little bit behind, but eventually that copy will also acknowledge the change, or it will actually go offline and we'll create another clone for you. Right? So what the fabric does for us is, firstly, it figures out who is the primary copy of those replicas. So we have a primary and a set of secondaries. And it ensures that you connect to the appropriate primary copy. And in the case that one copy goes down, it deals with provisioning other clones of those replicas for you and also routing your requests. Now, on top of that, we've built what we call our utility layer. So in our SDS service that exists today, This is the layer that lets you create an authority and create a container. In the new SDS service, the relational service, this is the layer that lets you create a server instance, right? When you create a server instance, it's not like you have a little printer there in the data center, a little ticket comes out, says, go provision a new server for Joe, and the guy runs out, racks a new server for you, right? This layer essentially says, okay, based on the cluster I have, I'm going to pick a location for that server to live, right? And by picking a location, we're not dedicating a box. What we're really saying is, where should your virtual master database live, right? That being one database in the many set of databases that you can provision for that server. That layer also deals with metering and billing, right? So we will be tracking how big those databases are, what types of resources are going to be consumed. Now, how do we bill? That's something we're still working out. We'll be announcing our billing plans along with the rest of the Azure Services platform before we actually release towards the end of this year. But regardless of what we bill for, there'll also be some set of analytical metrics available to you, right? How big is my database? How many transactions did it do? How much I/O am I doing? Right? There's 3 very simple metrics. For example, other ones, you know, how much network traffic did I send back and forth to this specific cluster instance? And the idea with those metrics is you can provide some insight into how that specific server is behaving, so you may choose to essentially make some changes. You may make some performance adjustments and so on. The other thing that this lower layer gives us is load balancing. And this is essentially a really, really great feature of the service. So the idea behind load balancing is, if we notice that one specific server that's hosting some of those databases is really busy, well, we can move load off it, right? How do we move load off it? Well, there's 2 simple ways. Firstly, we could take a replica that was a primary, and that primary is getting hit with queries and so on, and we can move it to one of the secondary replicas. So that's called leader election, flipping the role, the primary replica role. The other way we can do it is we can clone that replica, that is, move it, physically move it from one machine to another. And this is something that the lower layers actually provide for us. And our belief is that with the load balancing of where the data lives and where the requests actually hit, followed also by basic throttling and fairness in resource governance across all users of those machines, we can actually achieve a fairly high SLA. So let's flip to another demo. So this second demo here, need to stop our little WordPress application here. So what I have here is a very cheesy ASP.NET data binding application. And I don't claim to be the world's best ASP.NET developer. But what I wanted to illustrate with this very, very simple application is that all of the coding patterns that you use today to access data, whether that be simple data binding, whether you're using link query patterns, whether you're using an EDM type model, all of those patterns work today. And why is that? Well, the client libraries are going to work with this service. And all of the patterns that you see for data access today, they all talk through a SQL client library at some point. They have to, right? And if we make those SQL client libraries work, all those data binding patterns are going to work. And that's really the beauty of the approach that we're taking here. So if I just quickly run this application, I've got a copy of the Northwind data set here. So all we've got is a very boring page that lets me, I have a list of customers here, so I can find the customer, France Restoration, and I have a list of all of their orders, right? So nothing too exciting. I can edit those orders, I can update them, I can add them. I can also fetch them, right? So nothing spectacularly interesting here. Now, how did I actually do my data binding? Well, what I have in my application here is essentially a bunch of controls with a set of data sources. So here we have the customer's data source. I have a connection string that we'll take a quick peek at. So this connects to the Northwind database. So if we go flip open our web config, we'll actually see here, this is Northwind. It's using the managed client, so SQL client, and it's actually using SQL Express. Okay, so it's not using SDS yet. All right, and we'll come back to that in a second. If I go further down here, you'll see that I have my order details, data source. I have various queries, so this is finding an order by an order ID. That order ID is linked to a control. I have some inserts, some updates, some deletes. Again, this looks really boring, right? This is exactly the type of data access patterns that you use today in your applications. And that's really the whole point of this demo, right? I can also bind to stored procedures, right? So for those of you that like to use SQL Client directly, I have a stored proc here called getOrderDetails, given an order ID parameter, right? And I'm just using regular data binding. Now, what did I have to do to get this application running on SQL Data Services? Well, the answer is not a whole lot, really. I did two things. And the two things that I did are exactly the set of things that I did to get this running on SQL Express. Well, the first thing I did is I created my database, and I installed the schema and loaded the data. Okay? I had to do that with SQL Express. The second thing I did is I configured my connection string. Okay? So I told it what my data source was. So in ADO.NET terms, the data source is the server instance that I'd like to connect to. I told it which database I wanted to connect to. And in this instance, I told it how I was going to authenticate. So we're using integrated security on my Express instance. Now, conversely, if I wanted to make this work with SDS, well, what do? Well, the answer is I just change my connection string, right? I've already created my database within SDS. My server name is a server that I've called MIX09 at some domain name. My database name is Northwind. This is looking awfully familiar, right? And my user ID is Nigel at MIX09. Okay? So pretty much identical, right? And in SQL Express, I happen to be using integrated security to authenticate with that instance. SDS does not support integrated security, so I use a regular SQL username and password. So let's just quickly run this demo just to make sure that it actually works. All right, so there we go. Data binding Northwind against SDS. Now, what else could I do here? Well, what else do I do as a developer? Well, I might actually connect to a server explorer. Okay, so we have a server explorer here. All right, similar dialogue you're probably all used to playing with. Put in the name of my server, my database, and so on. Right. I can actually look at the tables. Okay. What about SSMS? So SQL Server Management Studio. All right. So here's SSMS connected to my demo server again on SDS. I can run some queries here. Again, nothing too exciting. Pretty much boring old SQL using the same old tools that you use with your existing SQL Server instances, right? And that's really the big deal. It's not about saying, wow, here's a great new programming paradigm for the cloud. We're saying, let's take what you do today on-premise that you're familiar with, that you know how to do, that you're comfortable with, and make as many of those patterns and practices work up in the cloud, right? Now, something that I couldn't do last year when I talked about SDS as a simple web service is we didn't have transactions, right? So here's what you might think of as being a fairly sophisticated stored procedure. I'd like to ship some orders to a given country. I have only so many orders that I can ship at any point in time, and I'd like to know how many orders I shipped, right? So we've got an update query, We've got some update returning results. I can output which rows I updated. And I want to find the orders based on when they actually were required, right? So if we go run that here, all right, so that was nice and fast. Not a whole lot of data in here, but it illustrates that you can take the same SQL that you use today, right, and you can essentially use those same patterns and practices up with SDS. And that's really the big deal, right? Boring old SQL still works in the cloud. All right, now, what are the compatibility goals here? So I'm not going to stand here and say, everything you do with SQL Server today is going to work, okay? Some of the things will work in our V1 wave. Some of the things will work post V1. And perhaps some of the things will never work because they just don't make sense in a cloud environment, right? So we've started to dig through what the compatibility level should be, right? Now, that's actually a much harder task than you might think. So SQL is actually a very mature database product. In many respects, it's like an application server. You can host logic in there. You can now host the CLR, right? So how much of that can we support while we're working through it? And our goals here are really around, let's take the common things that people do, right, and make as many of those things work as possible, right? And one of the things we're looking at is to say, well, how much time do you spend looking at the overall server boundary of your database versus how much time do you spend inside of an individual database? So I'll give you an example. There's many things that you can do in the master database with these things called DMVs, so metadata views. And they're used for analytics, and they give you physical resource information and provisioning information and so on. There's cases where you can connect to one database and reach across to another database on the server, right? Now, how much of the time do you spend doing that in your application versus using regular SQL for data within your specific database boundary? We think most apps spend more time inside one database than across those databases. So consequently, we're tipping the scale for compatibility inside of a database and then looking at the level of functionality we have to provide across those databases. The other point to make here is that the patterns and practices that we'll support in SDS, those same patterns and practices will work on your on-premise SQL Server. Why is that? Well, it's actually a subset of the existing capabilities that you have, right? And that's really a great thing. So as our practices emerge and we settle on the level of compatibility and functionality we'll support, we can actually say, if you build your applications like this, you'll be able to run them in the cloud and also on-premise with very, very few changes. And that's a very, very powerful concept. Thinking about, particularly if you're an ISV, you want to build an app and you'd like the option for that app to be run on-premise with the customer, but you may also want to be able to host the application for somebody. And knowing which features to use to let you move seamlessly back and forth is a great thing. The last point here is around multi-tenancy, right? So as I mentioned in the earlier slide, we will be actually hosting you on shared server infrastructure. And there's a few consequences of that. The first one is throttling and load balancing, right? So if you happen to be a really hungry or greedy little worker process on that server, and you're actually consuming all of the resources on that server, you can expect to be throttled, right? Ideally, if things are working correctly, we'll move your workload off to another machine. But at some point, you still won't be able to consume all of the capacities of that second machine. So there'll be cases where we'll slow your workload down, where we may actually reject some of your requests because the server is actually too busy, right? So that's one consequence. And then the second one is around size limitations and transaction duration limitations and so on, right? We can't be in a situation where you say, begin tran, insert row, and then you sit idle for hours and hours and hours, right? Why is that? Well, we're taking backups on the server for you. And if you have an open transaction, we can't truncate the transaction log. And that means the transaction log is going to fill up, and then everybody else on that server is going to be unhappy and so on. So we think there'll be some core patterns and practices, and if you fit within essentially the mold of these patterns and practices, your application should actually work very, very well. Now, the bar that we've looked at, we did a broad survey across a set of functionality that applications use. And there's a segment of apps that we're calling web and departmental applications. And the way that we define those applications is that typically the databases are at the smaller end of the scale. So by smaller end of the scale, we don't mean 100 meg, right? We mean gigs, but not tens or hundreds of gigabytes and so on, right? So remember, this fits in with the sort of SLA guarantees that we talked about. And they don't use a lot of exotic SQL features. You know, how do we find exotic and so on? I'll get into some of that in a little bit more detail. But they use vanilla SQL capabilities. They use stored procedures. They use triggers. They use tables and views and indexes and so on. But they don't use a lot of the more complicated DMV capabilities we might not be able to support in the near term. And based on that, we think we can get about 95% or more of those applications. And that's a huge class of applications that we believe can run either unchanged or with very, very minor changes. So what are some of the example compatibility bars that we might have? So I'm going to caveat this slide with likely, right? And the reason for the likely flag is that we're still figuring this out, right? But here, this should give you a flavor. So tables, indexes, views, stored procedures, triggers, constraints, table variables, session level temporary tables, intrinsic functions, right? Those things will just work, okay? Now, what are some examples of the stickier things that we're looking at, right? Distributed transactions, okay? Well, distributed transactions, by definition, are around essentially making a transaction consistent across one or more resource coordinators. So two servers can enlist in one transaction, and then you can do something called a two-phase commit that guarantees consistency of the data across those two servers. That won't be in the V1 scope. Distributed queries. Hosting of CLR code inside the engine. Why not CLR code? It's not like it's a big, scary thing. We actually think this is a great feature of SQL Server. But in order for us to host the CLR and make it work well with our throttling and load balancing, there's additional engineering work that we have to do there, right? Not impossible, very, very achievable, but not at the top priority of our list in the V1 timeframe. SQL Service Broker, that's distributed messaging capabilities. New spatial data types. And then last, but by no means least, physical server catalog DDL and views. What the heck does this mean? Well, this says we're taking care of all the physical management of the infrastructure for you, right? We're running you on shared resources, and you have no business understanding how we lay those files out. There's no reason for you to need to know about that. How many file groups do we have? How big's our log file, and so on. Essentially, we're taking away that, and we're essentially giving you an SLA around high availability, around a contract, essentially around the type of performance you can expect, and we're going to take care of all that for you. So hopefully from this slide, you get a sense of the type of features and functionality you can build, right? And I'm hoping you can leave this room with a sense of say, boy, my application probably fits that left column pretty well, right? There might be a few things that I see in the right column, and if I really scratch my head, I could actually remove some of those. Now, clearly there's going to be some applications where, for example, distributed transactions, that's something I really need, and it's very hard for me to unwind that, right? All that's going to mean is that we can't address those application needs yet, right? We can clearly start to support distributed transactions and other features like this in the longer term. So let's do a quick recap here. So how do clients connect? Well, they connect directly to a database. So if you think about SQL Server today, you connect to a SQL instance and you log into a database, okay? Once you've logged into that database, you can hop to any other databases on that server. So you could say use master, right? Use my database foo, right? Won't be able to do that in this model. Now, why not? Because your databases are spread across many servers, right? And if you connected to one database, you have session state on your session, right? Things like, what kind of ANSI defaults do I have? You might actually have an existing transaction running. You may actually have state, other state associated with your session. And if we let you hop to another database, we need to bundle all that state up and move it over to another server. And that's actually very difficult to do. So we're not going to do it. Now, you notice all of the demos I did, they didn't need that, right? They connected to a database. So remember the Server Explorer we had in Visual Studio. When I set up a connection in the Server Explorer, I give it the server name, I give it the database name. I'm connecting directly to that database, so I don't need to hop across it, right? Okay, the security model. So we're using regular SQL Server security, so username and password. So we authenticate logins. Logins get mapped to users. Users get authorized to access specific objects. So grant user A read permission on this table. Grant user B update permission on this table, and so on. You can also use roles within the database, and this is something that SQL Server has been investing more in through the releases. You have notions like a DDL admin role. Well, that's just a fancy term to say any user in the DDL admin role for a database has the ability to make changes to any object or create any object. All that works, right? Now, can we do better than SQL Auth logins? So for some of you, you may have standardized on using Active Directory to manage permissions in your enterprise, right? Well, we think we can, but it's not going to happen in this initial V1 wave. Why not? Well, there's a few complications. So if you've got Active Directory running in your enterprise, and we're running up in the cloud, we need to be able to federate, right? That is essentially logically connect your Active Directory up to the cloud so that when you go and log in to our data service, we know how to authenticate you as essentially an identity in your Active Directory. Now, there's a lot of very interesting technologies we have here. Microsoft has something called Geneva Server. It's part of Windows Server 2008, and it lets you federate your Active Directory. And what we haven't done is essentially glued that together with our identity system up in the cloud. And there's a bunch of other interesting work that has to happen in the client library layer to actually make those identities seamlessly transport across the wire. So one of the points I want to make here is that I've talked to several people about the change that we're making here, and people have asked me, how is it that you can credibly go from this simple web storage service that you had before and now offer as a relational service? Well, the answer is twofold. Firstly, the underlying platform that we had to build the SDS service as is today, that's evolved, right? We've continued to invest in that and invest in the functionality. The other part of this answer is, in terms of building that platform, we actually have a high-scale tenant within Microsoft actually running on it. So if you think of SDS running on top of this underlying platform, and another tenant, in this case it's called EHA, running on that underlying platform, using those two application patterns and so on, we've added more and more rich capabilities inside of that platform. So EHA is a high-scale archival service. So this is used for email compliance scenarios. So you can go to Microsoft and you can say, hey, I'm told I have to comply with this nasty thing called Sarbanes-Oxley, right? And what does that really mean? It says, I need to take all electronic communication and preserve that for a specific period, typically 3 to 7 years. And why do you need to do that? Well, you may get subpoenaed. Maybe you're a stock trader and you've been up to no good on the stock market. And then the essentially court comes along and says, we need to see Nigel's email for the last 7 years. Well, most companies don't want to deal with that. They'd like to outsource that. And EHA is a service that provides that. That service is running on the underlying SQL cloud and cluster infrastructure that we're building SDS, right? Now, why did they move to SDS? Okay? They were a second-generation service. So Microsoft had acquired the company. They're originally running on one of our competitive database products. That was then rebuilt to run on top of SQL Server. And now it's started to essentially reach the end of its life. Now, end of its life is really defined as where we'd like to take the business is limited based on the scale of the application. So the current implementation is limited to the largest size SQL Server box you can buy today. Now, of course, you can buy some pretty big boxes. It depends how much you want to spend, right? The issue here isn't how much data you can address by that server, because you could buy essentially a SAN, which is the size of a small building, right? It's how much processing can that server instance do. So EHA rebuilt on top of the SDS infrastructure, and this allowed them to scale out, right? So they're taking their large databases, which could be terabytes in size, they're breaking them up into what we call partitions, and they're distributing those partitions across the cluster of servers. And when a request comes in, it says, hey, there's this stockbroker called Nigel. We think he's been up to no good in the last 6-month period. I'd like to search for insider dealing as a phrase, right? What they do is they essentially go to a map. They understand where my data would live, so where Nigel's data lives, and it could live across many partitions. They then fan out that query. So by fan out, what we mean is we enumerate the partitions. We ask the underlying platform to give us a connection to each of those partitions. And then in parallel, we can fire those queries off, and we can essentially aggregate the data together, right? Now, interesting perf point here. So in their current system that they have today, some of those queries could take 20 to 25 minutes based on the data volume, right? Using the infrastructure that we've built with SDS, those queries are now returning in around 20 seconds, right? Now, there's not a whole lot of magic here. You're taking something that was largely sequential, and you're making it parallel, right? And this is one of the benefits that you get with SDS. So you could use the SDS service, you could provision your virtual server, and then a set of virtual databases to distribute your data across the cluster. And then when you need to address a specific query for your application, you could also fan out that request. And because those databases are going to be distributed across many servers, you can also achieve the same kind of parallelism. So what do we view some of the opportunities here? So partition databases is one example. So in the model we're delivering with SDS today, we don't expose partitioning. And what I mean by that is the database platform itself doesn't understand how your data is spread across many, many small databases, okay? You have to own that mapping in your own application, and you're responsible for spreading the queries across the different databases. What we'd like to do is push that into the service, right? And actually, that's what we've done in the underlying platform. And what we see right now is this layer that we're building on top doesn't expose the partitioning that lives underneath. So in the next wave after V1, we'll be exposing that partitioning. So you'll be able to describe a database that could logically be of unbounded size. You'll describe how your data is partitioned. That is to say, how do I break this up? For example, I may choose to partition on a customer ID or a region or a specific date and so on. And then the platform will essentially take care of managing those partitions, changing the sizes of them based on load as they grow, splitting them and moving that data to different clusters, and then also dealing with taking a query that's targeted at the partition database and routing those requests and aggregating the data and returning it to your application. Geolocation and geo-redundancy. So with Azure today, we just announced at MIX, it's not actually available in the CTP. Azure is going to offer you the ability, when you create a compute instance or an Azure storage instance, you can specify something called a region, right? And a region you could think of as being East Coast, West Coast, and so on, right? The idea is that you want to co-locate your application with your data, right? We'll also be providing a similar capability. Our goal is to integrate extremely well as part of the Azure platform. So while you take your app and say, I'd like this app to be on the West Coast, you'd be able to say, I'd like a SDS virtual server to also be on the West Coast, please. So I have low latency interacting between my code and my data. The second one is also interesting, geo-redundancy. So this is the idea that we'd like to be able to offer geo-replication between these data centers. So eventually you'd be able to say, I'd like my data to be highly available, and I'd like to be able to to address data center failures. If for any reason a data center goes offline, I'd like to essentially fail over to a secondary data center. This is something that won't happen in the V1 timeframe, but this is something that's very much on target for where we'd like to go. third one is distributed query, so being able to federate my queries across servers. Security we've already talked about. And the last one, just to briefly touch on, so if we go back to the chart we had at the beginning around consolidation where we start, in the platform we have the ability to dial that, right? That is the idea that we could give you a whole server or a set of servers. We're starting out by giving you a slice of a server, but we'd also like to essentially offer differentiated SLA. If you think you can take a whole server or many, many servers, we'd absolutely like to give that to you. It just won't happen in a V1 timeframe. So what's our release plan? So today what we have is essentially what we call internal adoption. So we have some number of SDS clusters speaking the new TDS and relational service. They're actually running in Microsoft's data centers today. Those are not facing to the internet yet. When will they start facing the internet? We'd like to do that in the May timeframe. So that's where we're starting an invitation CTP process. We'll start to work with a relatively small set of customers. Small, probably tens of customers, not hundreds or thousands, on starting to consume the service and give us early feedback. We'd then open that up to a public CTP in the July timeframe. Now, for those of you that happen to be using the SDS current web service, this ACE model, Authority Container Entity, that's essentially the time that you could actually have access to both services side by side and do a migration. Now, do you have to wait to that point to start? Well, if I landed my talk correctly, you could start today, right? And how could you start? Well, you start programming on SQL Express or SQL Server, right? Because if your application works on Express and SQL Server, it should work, if we do our job right on compatibility, unchanged when you move to the SDS relational service. And then finally, there's this term we're using called commercial availability, and that's for the whole breadth of the Azure platform. Our goal is to make this commercially available towards the end of this calendar year. And by that, we mean that's when we start charging for it. Now, a lot of people have said, well, what are you going to charge for it? I really, really need to know. We're still figuring that out, and we promise to reveal details of that probably sometime in the summer timeframe. Right? There's a lot of very interesting debate going on right now about what makes a good billing model and so on. So if you have feedback on what you'd like to pay for, what you'd be willing to pay for, we'd love to hear it. All right, lastly, in closing, so we have essentially the foundation of a relational data platform. That same data platform uses SQL Server code. So we took the code, we extended it, it's running, it forms the basis of the current SDS service, the new relational SDS service, and it's also running the EHA archival application inside of Microsoft today. So it's real. It's actually there. We're focusing on making this relational by PDC. It's very, very core to Azure. So we've heard from many of you, hey, I like this Azure thing. I love the fact that I can run my application. This week saying, well, I can even run more of my applications. Now you support PHP and fast CGI, but I really need the power of my relational database. It's there. It's going to be part of Azure. So last but by no means least, there's some little cards on your seat. If you could just take a few minutes to fill these out. I'm told the scale goes to 5, but you can mark it at 11 or something like that if you think the talk was any good. And then I will take a few questions now, and I'll be staying in the room afterwards for about 15 minutes or so I can take some more at the podium. We do have a team blog that I'll refer you to. We actually started revealing our relational roadmap about a week before MIX. So there's actually some more details available on the blog about this. And there's also more details at our MSDN Dev Center. Thank you. Question?
I just have two quick questions. Assuming I get access to the CTP, how stable are the APIs today? They look fairly stable.
Could you speak up a little? I can't hear very well.
Assuming I get access to the CTP, how stable are the APIs? They look fairly stable to me.
So the question is, if I get on the CTP, how stable are the APIs going to be?
If I build something, a solution right now.
They'll probably be very stable because if you look at it in broad terms, there's two APIs. There's how do you provision, okay? So we didn't talk too much about how I provision a server, but the goal of the way that you will provision a server is you will be able to go to the Azure Services portal and create a new server instance. Everything that you do on the Azure Services portal, whether it be for SDS or Azure Compute and Storage, we'll be exposing APIs for those. So you'll actually be able to programmatically create those, right? So that's one thing. Then how do I create databases, users, and logins? Well, that's the same way you do it today. You connect to your master database, right? You then say create database foo, and then you say create user, create login, right? So those would be very, very stable.
Another quick question is, you know, there are keywords of the cloud. You know, I think like turnkey is repeated often.
I'm sorry, I can't. Could you?
There are keywords that are associated to cloud computing. You know, turnkey, for instance, or elasticity. I didn't get a sense for how elastic was, you know, SQL data services, knowing that it's probably hard to make them very elastic, but.
So I think your question is, there's this term that people obviously use called elasticity,
yeah.
Right? How do we view that in SQL data services?
Yeah.
So in our model, the elasticity is the scale out portion, right? So we think it's elastic in the sense that if you need another server, you can provision it. If you need another database, you can provision it.
But elasticity is this kind of real-time or near real-time effect. You know, I understand you can scale out, but being elastic is just a tiny bit more where, you know, you have a very heavy load coming and you're able, you know, the system is able to react and provision automatically or, you know, some instances so that it can respond to the load.
Right, so the other side of the elasticity is where the load balancing capabilities come in. So that's the idea that if your load happens to be hitting a server, and that server doesn't have enough capabilities on it right now to address that load, we can firstly fail over to another server that has your secondary replicas on, and that will essentially move the load to that server, right? And then if that server itself is still unloaded, we can also provision another server for you and actually move your data off those other machines to these secondary servers. So in terms of the capabilities that we have in the platform, those are there, right? Now, the questionable part is how much progress we make in that. For example, if you really need to go from a small part of a server to a whole server to many servers, right? You've got a very interesting workload to be able to go switch from that over to this broad spectrum. We certainly think that moving you from essentially part of a shared server to having a server with just your database on it, we think that's achievable, right? Moving it to a point where essentially a single server is no longer big enough, that's where the partition databases come in, right? Where essentially, regardless of how your data is spread across many servers, you have the same programming model contract, and then it's largely hidden from you how many partitions you have, how many servers you're using.
Thank you.
Hi Nigel, Jamie Thompson here from Conchango in the UK. I just got a couple of quick questions. Firstly, can you make the slides available? Secondly, I would like to just drill into the data sync that you talked about at the top of the session. That looks quite interesting, syncing between the cloud and on-premise. Is that going to use replication?
Yeah, so in SQL Server today, we have something called the Microsoft Sync Framework. And that's actually a product that's been available in the marketplace for a while now. We're using those same protocols. So this was Project Harmonica. You may have heard of it by that name. We're using exactly the same sync endpoints and so on. So if you have an app that's using that framework today, you could be using it on-premise between devices to servers and so on. You'll now be able to add your SDS virtual server as essentially another part of that.
Okay, cool. Yeah. And the slides, can you make those?
We'll probably post them through the blog in some form over the next few weeks.
That's cool. Thank you.
Yeah.
Can we expect a developer fabric similar to the local Azure developer fabric so that we can develop against the limited subset of functionality?
Yeah, so are you going to get a cloud in a box the same way I had it today? We're still discussing that, and we're not sure yet. And the reason we're not sure is if we do our job right on the compatibility story, you could use SQL Express as your developer fabric in a box, right? Because the only APIs you're largely missing at that point are the APIs for provisioning a server, right? And if you focus on building your app within a database, largely, provisioning a server locally is install SQL Express. and then you go create a database, right? So we're not really sure giving you sort of SDS in a box, if you have Express and a high compatibility bar, is really much of a gap. And if we look at the cost of doing that for us, it's fairly expensive relative to doing more in the compatibility bar.
You had mentioned at the beginning that there were going to be some like size limitations of how large a database could be, or I didn't quite catch that exactly what you're referring to. So if you could explain the limitations of the size of the database and what those were.
Yeah. So earlier in the talk, I said yes, you can have a virtual server, you can have many virtual databases, but each one of those virtual databases are going to have capacity limitations, right? Now, we still haven't settled on what the exact limitations are going to be, right? But you can imagine that these databases themselves can be gigs in size, you know? Not tens of gigs, not hundreds of gigs or terabytes, gigs in size. So a typical number we're bouncing around is, say, 5 to 10 gig. Now, when we've talked to customers about that, they said, oh, only 5 gig, I'm not sure that's big enough. When they actually go back and look at their applications, most of the apps that we're focusing on in the V1 timeframe, these web and departmental applications, the big ones are 3 gig, right? So we think the 5 to 10 gig range actually hits sort of more than the sweet spot and will actually be sufficient. Now, for the apps where that's not big enough, they would then have to move to essentially this partitioning pattern, where they, common term is sharding, where you shard your data across multiple databases. And essentially, the application understands how to route the request to the appropriate database. And that's something that once we do our partition databases, should let you push your sharded knowledge back into the data store, and it can deal with the data management, size, and scale issues for you.
All right, thanks.
Yep.
On the slide where you showed what is and what isn't in V1, you didn't list full text indexing. Will that be in V1?
Full text indexing, that's something we're still discussing. There's some more work for us to do to get that working. So a little bit of background. So CloudDB, the underlying platform that we have that we built over the last few years, was built around the SQL Server 2005 kernel. Over the past 3 to 4 months or so, we've been moving from the 2005 base to the 2008 base. Now, the full text search capability in SQL 2005 used MS Search, so it used an external full text indexer. In 2008, they shipped something called integrated full text search, which is just a fancy term to say they no longer use the MS Search stuff. They store the full text indexes inside the database catalog itself. And we have to do a bunch of engineering work to essentially light up full text search in 2008. So we're still looking at the relative cost of that relative to the other compatibility bar. So our goal is to essentially come out and define roughly what the core feature set is going to be around the CTP timeframe, so around the May timeframe and so on. We'll be able to settle on that.
Okay, thank you.
Yep.
Do you think pattern and practices will develop some functionality around support for multi-tenancy? Because you talked a little bit about that in your talk, but I don't think it necessarily belongs to the core, unless you say otherwise. But do you plan to develop a strong support for that, thinking that there are a lot of people that want to build solutions for in a SaaS mode?
Yeah. So your question's regarding multi-tenancy, and I'm assuming it's if I'm an application that there's a multi-tenant application. What's the best patterns and practices of how I could map my application onto this architecture? That's actually what we call the SaaS ISV scenario. And that's something that we would like to deliver on. And by that, we mean this provisioning layer on virtual servers and databases and so on, being able to provide richer functionality if you're a multi-tenant application. For example, knowing which of your tenants are associated with which databases. Knowing how many resources were consumed by that individual tenant. Eventually, being able to offer billing as a service, right? The idea being, well, I know Nigel, the tenant, used this amount of resources, so I'm going to essentially directly cut a bill for that particular individual. That's something that we think we can deliver a little bit on in this initial wave. we'll also be able to deliver the patterns and practices, which is saying, this is how we think you could build those applications today based on what we have, and here's how we think the platform is going to evolve to allow you to push more and more of that application down over time. Yep. Okay, one last question.
Okay. Regarding your geolocation,
yep.
Is there any way that I can specify whether my application is to run in Europe or in the US?
So geolocation, in some sense, where are we going to offer geolocation? Our focus right now for the OLAP Azure platform is North America. So that's our first wave. Beyond North America, we think about Europe, Asia, APAC, and so on. We don't have a time frame that we're ready to announce yet around that, but we will be going outside America, right? And we've heard from a lot of customers, particularly those in European regions, that said, well, I can't store my data in North America data centers. There's this thing called the US Patriot Act, right? And it violates a whole bunch of European law and so on. So the Azure platform will go to Europe and beyond that. And our goal is to move in lockstep. So wherever you have Azure Compute, Azure Storage, you're also going to have SDS. But that's not going to happen this calendar year. Yep.
Thank you.
Okay, thank you.